In your textbook, the first problem it has to do with capital budgeting, and it's actually a very interesting problem. I like it because it's kind of like my other expertise in finance. So here you have a very common problem, right? It's a budgeting problem. Some of you may have already seen something like this in your jobs, in whatever role you play in your company, in your firm. But you have a few different possible things that you can spend money on. You can spend money on a plant expansion, a warehouse expansion, you can buy new machinery, or you can invest in new product research. Okay, those are the things that you can do, let's say, for next year. And you do have a fixed budget, obviously. If there was no budget, there wouldn't be any constraints, and you would just do them all without any type of analysis. But we live in a world of scarcity and in a world where everything is limited. There's always a limit. Um, so in this case, the top row, those are the present values of each of these investments. The present value is just the value. It's always hard for me to explain this without being in a finance class. But it basically is how much is this worth to you? So plant expansion it has the highest value, 90,000. It doesn't mean that you have to do it because maybe plant expansion is going to cost you $1 million. Why you spend $1 million to get $90,000 worth of value? Maybe you can spend $1 in new product research and get 37,000, which means you will get $3,699 in value. So that's why we have to budget these things using present values, etc. So that's how much you're going to get in return. Now, each of them, to make things more complicated, right? Each of them has a different capital requirement per year. So we're not just looking at two pieces, right? How much I'm going to get, how much I'm going to spend. No. It's how much I'm going to spend per year, because every year my budget is going to vary because these are multi-year operations. So it's complicated and much closer to the real world, right? Let's say that the plant expansion has $15,000 requirement the first year. Year two has 20,000, year three, etc., etc. And I have each of them listed here. Again, you can look this up on your textbook and get more detail. Notice how the new machinery is actually the cheapest. You only need to spend $10,000 the first year and $4,000 on year four. Nothing in the middle, and that's done. Okay, and then over here I have the total capital available for each of those operations. I'm sorry, for all the operations combined. Sorry about that. So for example, the first year, I have $40,000 available to me. Well, let's say, what would happen if I decide to go for all of them? Let's say that you decide to go for all of them. Could you finance the first year? Well, let me take a look. Of course, this thing now is on my way. Can I move it? All right, yeah. The sum of these four is 50,000. I only have 40,000. So I already know that I can't do it. Okay? I already know that I cannot just go for all of them. That's why we need to figure out which of these four we should do. Which one or which ones? How many of them? All right. So now we're going to go to our solver. Okay, so below this line, this is our solver now. All right. So to make it simpler, we're just going to use, place 1,000 there. So 90,000 turns into 90, 40,000 turns into 40, 10,000 into 10, and 37 into, you shouldn't say that. Better, right? And 37,000 into 37, okay? I just deleted the solutions that I had before and I was playing with it. Okay, so then you have your solutions. You're going to maximize the sum product of these two. So far, everything is exactly the same. You're going to have your constraints here, right? So your constraints are very simple. The sum of each of them for every year cannot be more than the capital available. This is actually quite This is a very simple setup compared to some of the things that you've done by now. This is very simple, right? Just make sure that in any given year, you don't spend more than what you have. Simple, okay? All right. What's key is what happens next. We go to Solver, and look what's going on here. Oh, I don't know where to put it. Okay, I'll leave it there for now. So you set your objective, Z, to maximize by changing these guys over here, and you have your constraint there, less or equal to this. Everything is exactly the same as you've done before. No surprises here. But it's this guy up here. Look at this one. You see it? I'm going to delete it and I'm going to add it back so you see how I did it, right? I'm telling Solver that these cells right here, my solution is going to be a binary, and click OK. Why? Because all I want Excel to tell me, Solver, is should I go for it, yes or no? A yes is a 1, do it. A 0 is a no, don't do it. And if you think about it mathematically, the moment you place a 0 here, that's going to multiply times that, and it's going to basically null this project. If there's a solution of 0 here, it's going to wipe out that project. Okay, so I'm going to solve. Solver returns the following: a 1, a 1, a 1, and a 0, meaning do the plant expansion, fund the plant expansion, do the warehouse expansion, do the new machinery, do not do the product research, do not embark in new research, okay? That will give you a maximum present value, maximum value of 140. That is the best you can do. Do you see that? 1, 1, 1, 0. Now, you're probably wondering, like, why did they turn green and red? Well, this is something that I'm going to do on the following problems, just to give you, some new techniques. And it's also very easy to the eye when automatically Excel does something graphical to the solutions to help you see the solutions better. So you see here, Excel turned green the cells with a 1 and red the cells with a 0. The way you do that is, how do you do it in my new Excel? You go to Home. I need to format my. This is my new Excel. Conditional formatting right up here. Okay, and you can play with this if you have the time, or if you're curious about it. I'm going to show you a few other examples, but that's how I did it.